So our lesson for today is about current and the resistance. Ayan. So pag sinabi natin current sa subject natin or in general, di ba current means something is moving. Ay, something is moving. Pag electric current, yung pinaka subject natin, so ganun pa rin, something is moving. Pero pag electric current siya, yung charges naman yung nagmo-move. Okay? Sa Tagalog yata, kuryente. Current. Kuryente. At ang nagmo-move ay yung mga charges. Okay? So, the most practical application of electricity deals with currents and then these charges move through some region of space. Okay? So, halimbawa, yung lighting ba, yung kidlat, merong current. Okay? If there's a motion or movement of charges from the sky going to the ground, so that means merong ang current. So yung kasi tinatawag natin current, so dapat merong motion or movement yung charges natin through some space. So in general, ayan, current is the rate of flow of charge through some region of space. The rate of flow of charge. Okay, alam niyo sa klase minsan sa English, sinasabi nila, ang flow of current daw is redundant. Do you agree? Do you agree na ang flow of current daw is redundant? Ako minsan, namamali din naman ako. Kasi yung current daw mismo ay flow na siya. So, parang nagiging redundant daw yung parang flow of charge. Pero syempre nasanay na tayo, di ba? Yung flow of current. But as much as possible, I try to correct myself na flow of charge lagi na sinasabi ko because flow of charge is the current itself. Okay, parang sinabi nyo daw na ATM machine. So ATM machine is also redundant or it's also wrong because ATM is already a machine. Kasi yung M doon sa ATM is machine na. Kaya hindi tama na sabihin mong ATM machine. Okay, isa pa yung flow of traffic. Malimit ko na itong naririnig sa mga reporter yung daloy ng trapiko. Oh, that's also daw redundant because traffic itself is already the flow of vehicles. Parang redundant mo daw yung flow of vehicles pag sinabi mong daloy ng trapiko. Ayan. Yung mga ganyan ba? No, at least medyo maging aware kayo on how to use the proper words in saying them. Ayan. Yung mga ganyan. Okay? So generally, ang formula natin ng current is yung charge over time. Kasi that's the rate of flow of charge through region or of space. Ang unit ng current natin in SI is ampere at ang 1 ampere is equal to 1 coulombs per second. So, ang ampere is, di ba unit ng charge is coulombs, time is second, so coulomb per second is 1 ampere. Okay, ang symbol natin for current is I. Kasi ang charge, ang symbol natin ay Q. We think of it as quantity. Pagdating naman sa current, you think of it as intensity. I, intensity. Ayan. So yun yung symbol natin for current, it's I. Okay, so meron tayong dalawa pang klase ng current, yung average current at saka yung instantaneous current. Pag yung average current, so that's equal to delta Q over delta T or the total change in the charge over the total time for that change in the charge. Okay, so example, meron tayong conductor dito at meron siyang cross-sectional area and charges are moving, positive charges are moving in this direction. So that means the direction of the current is in this direction, flowing through this area. So at a certain time, ilan yung charge na dumaan or yung charge na dumaan dito sa cross-section na to given na particular time. So yun yung ating average current. Okay, so that's delta Q over delta T or that's equal to Q final minus Q initial over T final minus T initial. Okay, pagdating naman sa average current, instantaneous current, ayan. So that is the limit of the average. Okay, so that's the limit of the average current as delta T approaches 0. Or in short, if we are given the equation of the charge, okay, so get the first derivative to find the current. Ayan. So get the first derivative. So dq over dt. Okay, now what is the direction of the current? So meron tayong dalawang klase na, I think I mentioned this before, meron tayong dalawang klase ng direction. So yung una yung tinatawag nating conventional flow. So yung conventional flow, yung mga charge natin are moving from the positive to the negative charge. Or yung current natin, nagsisimula siya or lumalabas siya sa positive. Okay, so that means we are following the direction of the positive charges. Okay, so meron tayong battery at ang polarity niya dito ay positive, dito negative. So susundan natin yung direction ng mga positive. Okay, so ibig sabihin kung positive dito at meron tayong positive charge, yung force between them is repulsive. So itutulak ng positive polarity yung charge na positive pa ganyan. Okay, sa negative kasi, di ba attractive yung force, kaya repulsive siya dito, attractive siya doon, kaya motion niya is ganyan. Okay, so that is the conventional flow. Okay? But in reality, ang nagmo-move ay hindi naman yung positive, yung negative, which are the electrons. So yun naman talaga yung nagmo-move at yung flow natin is from negative then going to positive. Kasi negative, okay, negative, the force is repulsive, and then negative to positive, that's the force is attractive. Kaya motion is pabaliktad ng conventional. But that is the actual flow kasi nga, yung negative naman talaga yung nagmo-move, hindi naman yung positive. Pero ngayon pa lang sasabihin ko na sa discussion natin until we move to other a lesson na merong charges na involved, ang motion natin ay yung mga gumagalaw ay yung mga positive. Kasi conventional flow yung susundan natin. Okay? At yung mga nagmo-move na charges na to, tinatawag natin silang charge carriers. Okay? Ayan. Okay? Okay, kung nagmo-move sila, so that means meron silang speed. So, merong relation ng current at saka yung speed. So, syempre, kung may current, they're moving. At yung motion ng mga charges na to ay tinatawag nating drift speed. Ayan. So, halimbawa, meron ako isang conductor dito. Ayan. A conductor dito at meron siyang cross-sectional area na A. At gusto kong malaman kung ano yung total charge dito or ano yung current dito. Okay, unahin na natin dun sa mga charges. So, yung N natin is the number of charge carrier density. Okay, so ang unit niya is number of charge per volume. So nakadepende yan sa material. So let's say ang copper at saka aluminum, hindi sila pareho ng charge density na N. Okay, gusto ko malaman kung ano yung total charge nandito sa conductor na to, na volume of conductor na to, yung charge density, i-multiply ko siya ng volume. Okay, para mawala yung meter cube. I-apply natin ng volume. So yung number of charges natin is equal to charge density times volume. But if you want to get the volume of this, ayan, so since cylinder siya, so kukunin natin yung volume ng cylinder. So that is the cross-sectional area at saka yung height niya. Ayan. Is equal to A times delta X. So substitute natin siya dito. So the total number of charges is equal to the charge density times yung cross-sectional area times delta X or yung length or height ng conductor natin. Okay? At kung gusto natin kunin yung total charge ng mga charge na to, so that's equal to the number of charges times the charge of each. Di ba ang charge ng, let's say yung electron natin is 1.6 times 10 to the negative 19. Okay? Times natin dun sa number of charges, so we'll get the total charge. Ayan. Okay? So, yung total charge natin, ang NT natin is this. So, substitute natin siya dito. So, we'll get the charge density times area times length times Q. Okay? Pero, since meron silang speed, okay, kung gusto natin kunin ng speed, okay, so that if they will travel the delta X with the given time, so therefore, the speed is equal to delta X over delta T. Delta X over delta T. If you want to get the delta X, so that's equal to, cross-multiply lang natin yung delta T. So, VD or the drift speed times delta T. At i-substitute natin siya dito, yung delta X. So, that means we will get delta Q or the total charge is equal to NQVD delta T times Q. Kung i-divide natin yan ng delta T, so that means delta Q over delta T is equal to NAVDQ. But delta Q over delta T is current. So therefore, current is also NAVDQ. Okay, yung VD natin, that is the drift speed. Drift speed. Okay? Class, ang drift speed na yan is an average speed kasi yung motion ng charges natin is in random. Kaya siya naging average. So if you will get to see the motion of these charges in the conductor, yung motion nila is in random. So dahil imagine ninyo yung motion ng mga charge natin sa isang conductor wherein the molecules or the atoms of the conductor which is solid ay compact sila. Kaya yung motion niya is in random. So random talaga yung motion kasi nga yung mga molecules natin ay compact at madami sila or yung atoms natin. Kaya yung motion ng mga charges natin is in random. Ayan. Okay? Kaya class, it is described that the drift speed is a very, very slow motion of the charges. Mabagal ang drift speed. Kaya kung meron tayong sagot na drift speed na 1 meter per second, actually masyado nang mabilis yon. Ang mga motion natin ng drift speed ay mga times 10 raised to -3, -5, -6. Kasi ganun sila kabagal. Ganun kabagal yung motion ng charges. Even though they're moving fast, yung motion nila horizontally in terms of length and time ay masyadong mabagal. Okay? May question? Okay, and that is described, kaya siya average class. Hindi naman kasi dire-diretso yung mga charges natin nag-move from left to right or right to left. They are moving in random. Okay, at ang ina-average kasi natin siya, remember average speed, it's delta x over delta t. Ang importante ay yung length na tinravel nila over the total time to cover that distance. So distance lang over that distance. Okay? Ayan. Okay. Ako. Kung wala kayong question, so may question naman ako. Kung dinidescribe natin yung motion ng charges na masyadong mabagal, bakit pag meron akong switch, okay, pag sa ilaw sa bahay ninyo, ayan, bakit pag tinurn on natin yung switch, automatic, sumisindi yung ilaw. Dinidescribe natin na mabagal yung mga charges. What do you think? We're saying na mabagal ito, pero bakit pag sinindi natin yung ilaw, automatic naman siyang nasisindi? Okay, so the answer is, ayan. So I think yung sagot ni John, Decena. Okay, class, remember the wires are solid. And yung mga atoms ng solid, if you will describe them, di ba compact sila? Okay? And hindi naman natin hihintayin yung charge dito. Halimbawa, tinurn on natin yan. Hindi naman natin hihintayin yung charge dito na makarating siya doon sa light bulb natin. Kasi sabi nga ni John, meron ng mga charge kasi dito. Or meron sa dulo ng wire natin ay meron noon ng charge. So meron ng mga molecules or atoms dito. Ang kailangan lang gawin is may magtutulak doon sa pinakadulo. Pag meron ng charge na nag-move dito, automatic, syempre magtutulukan lang sila, meron nang mag-move doon. Meron naghihintay doon. Kaya pag tinurn on natin dito, hindi naman natin hihintayin yung charge dito dahil meron ng charge agad doon na automatic na makakapunta na sa ating ilaw. Kasi yung mga charges natin, sila yung nagdadala ng energy. So matatransfer na agad yung energy doon sa ilaw natin. Kaya automatic, pag sinindihan natin ito, automatic na iilaw. Kasi meron na ang nakapile doon o nakastock doon na charge na sila na yung agad na makakapunta doon sa ilaw natin. Kaya meron din nagtanong sa kanina, sabi sa, Sir, kung ganun yun, may charge na pala yung kuryente, bakit hindi tayo nakukuryente pag hinawakan natin yung kuryente, yung wire lang? Ba't hindi tayo doon nakukuryente? Sa bagay, may point naman siya, no? Kung may charge na, hinawakan natin, pero ba't di tayo nakukuryente? It's actually a good question. Good observation. What do you think, Clarence? Parehong charge dahil sa covers ng kuryente, sir. Or di nagalaw yung charge dahil po ba sila skin, sir? Di po. Okay. Okay, so madami kayong sinabi. Feeling ko ang pinakamalapit yung sagot ni King na di nagalaw yung charge. So question class. Babalik tayo sa basic paano nagkakaroon ng current. Kung may wire lang, tapos hinawakan mo, ang tanong, may motion ba ng charge? May movement ba ng charge? Okay, wala. So, ibig sabihin, walang current. Walang kuryente. Kasi wala naman motion ng charge. Ay, at least, di ba? Alam natin yung mga, tama kayo. Tama. Gusto ko mga ganyan na conversation natin. Feeling ko nakakatalino, di ba? Nakakatalino. Yung mga ganyan kasing usapan. We're talking about ideas. Ayan. Okay, ang nagpapamove kasi sa charges natin, yung tinatawag na electric field. So later, I will be telling you what electric field is. Okay? So yun, kasi wala naman talagang current because there's no motion of charges. Kung merong movement or motion in charges, so merong current. And since walang current. Okay? So in summary, ayan, so meron tayong iba-ibang ways so paano kunin yung current. We have the general, we have the average, we have the instantaneous, and we also have the current with respect to current density, area, drift speed, and the charge. And yung drift speed natin is also the same as the length of the conductor or the distance of the conductor over the total time to travel this distance. So example lang natin. Okay, so next one is yung tinatawag nating current density. Ng unit niya, ang symbol niya is J. Ayan. Current density, J, so that's equal to I over A. Ayan, I over A. So that is the formula for current density. Ayan. So halimbawa, meron tayong current at yung meron tayong conductor at yung cross-sectional ng conductor ito at dito dumadaan yung mga charges natin kaya nagkakaroon tayo ng current. At yung current density is yung total charge na dumaan dito sa cross-sectional area natin. At ang unit ay ampere over meter square. So yun yung ating current density. Okay, importante ang current density kasi ang current density ay nire-relate siya sa conductivity. So yung conductivity ng isang material, okay, property siya ng isang material which allows the material to freely move the charges. Kaya ang mga conductor yan. So free na nag-move yung charges or yung current. O free na magkaroon ng current. So hindi niya binablock yung mga charges natin from moving. Okay, ang conductivity daw is actually the ratio of the charge density, current density, at saka yung electric field. Ano ba yung electric field? Yung electric field, siya yung parang force na nagtutulak dun sa mga charges natin. Kung ito yung field, para yung gravitational field, na pag merong mass doon sa gravitational field, let's say ng Earth, di ba nag-exert ng force yung Earth na i-attract niya? So parang ganun din yung electric field. Ang electric field naman, pag merong charge na napunta sa field na yan, so nagkakaroon ng force at nagmo-move yung charges natin. Kaya mga battery natin, they are not source of charges. They are source of electric field. At yung electric field na to, yung nagpapagalaw sa charges natin. Okay, yung electric field yung nagpapagalaw sa charges natin. Okay? Okay, so meron daw relation ang current density, proportional daw kasi yung current density doon sa electric field. At kung isusulat natin siya mathematically, na yung yung current density ay equal siya sa sigma times the electric field, where sigma is the symbol for conductivity. So Joe, so current density is equal to conductivity times the electric field. At yung relationship na yan is pinroved din ni George Simon Ohm sa kanyang law. Yeah. But this is not the Ohm's law na alam ninyo. Feeling ko hindi ito yung common na Ohm's law na alam natin. Pero ang sinasabi ni Ohm sa kanyang law ay that the ratio of the current density to the electric field is a constant sigma which is independent of the electric field producing current. Or the conductivity daw is equal siya sa ratio ng current density at saka ng electric field. Ayan. So, yan yung sinasabi ni Ohm sa kanyang law na tinatawag nating Ohm's law, which is not a fundamental law of nature because not everything obeys this law. Kaya hindi siya fundamental. Okay? So, this is also an empirical relationship valid only for certain materials. That's why it's not a fundamental law of nature. But most metals obey this law. Okay, so that's our Ohm's law. Okay? So next one is that's conductivity. So next one is the resistance. Ayan. Ang resistance naman is something that opposes the flow of charges. Ayan. It's something that opposes the flow of charges, yung resistance. At yung ratio, ang current daw at saka voltage, yung current at voltage, so proportional din sila. At yung proportionality nila is what we call the resistance. So R is equal to V over I. Okay? Yung ratio of proportionality ng voltage sa current is the resistance. At ang unit ng resistance natin is yung ohm, the omega, yung symbol na omega. That R is equal to V over I. Okay, 1 ohm is equal to 1 volt per ampere. 1 volt per ampere. Okay, so that is the resistance. At yung mga components, circuit components na may mga resistance, at yun lang role nila ay mag-resist ng flow of charges ay what we call the resistors. So yung mga resistors na to, ginagamit sila para i-limit yung current natin or bawasan yung current. Okay? So, yan yung resistance and then yung mga resistor. Now, let's go to the conductivity as resistivity. Ang resistivity naman, ito naman yung inverse or reciprocal ng conductivity. So, baliktad sila. Kung mataas yung conductivity ng material, ibig sabihin, mababa yung kanyang resistivity. Or vice versa. Kung mababa yung kanyang conductivity, mataas naman yung kanyang resistivity. So mostly, yung mga insulators natin, mataas yung resistivity nila. Kasi nire-resist nila nga yung flow of charges or nire-resist nila yung current. Ayan. Okay. So, nakikita nyo ba? Parang hindi nyo nakikita ang resistance values natin. Masyadong maliit. Okay. Ilalakyan ko na lang. So, I'll just show you. Ayan. So, ito yung mga resistivity ng mga common materials natin. So, class, kailangan yung tandaan na ang mga value na to is lahat sila ay under 20 degrees Celsius. Okay? So yung mga resistance na yan at saka yung resistivity na yan ay nasa 20 degrees Celsius sila. Kung titingnan natin, anong may pinakamababang resistivity? Okay, may pinakamababang resistivity. Hindi ko nakikita yung cursor ko. Yung silver. Ayan. Okay. So that means ang pinaka-best na conductor na neutral or element na yan, it's a silver. Kasi siya may pinakamababang resistivity. So ibig sabihin, siya may pinakamataas na conductivity. Pero siyempre, pinaka-popular yung copper kasi abundant siya at saka mura siya. Okay, not silver. Ayan. Ngayon, saan natin nakuha yung formula ng resistance relating resistivity? Okay? Okay, so paano ba natin yan nakuha? Paano naging ganyan yung formula ng resistance? Okay, pupunta tayo sa Ohm's Law. Okay, so ang sabi sa Ohm's Law, okay, ang conductivity daw ay equal siya sa J over E. So J is the current density, na yung current density ay equal siya sa current over area. Wherein yung electric field natin, ayan, so kung meron tayong electric field, okay, tapos may dalawang point, so nagta-travel dito yung charge natin from one point to the other, okay, sabihin na natin ang distance between the 2 points is D. Yung voltage or potential difference between these two is equal to ED. Ayan. The electric field times the distance between 2 points or yung potential difference. At yung conductivity natin is 1 over resistivity. I-substitute natin lahat. Now, 1 over resistivity is equal to I over A all over, okay, ang E natin ay V over D. V over D. Ayan. Okay? So, therefore, ang ang 1 over resistivity, outer, so that's equal to I times D over V times A. Okay, cross multiply natin yung V at saka I, so V over I is equal to rho at yung D gawin nating length, rho L over A. Okay? So ang sabi natin sa resistance, ang resistance daw ay yung ratio ng voltage at saka ng current. So therefore, R is equal to rho L over A. Ayan. Rho L over A. So dyan ang galing yung formula ng pagkuha ng resistance ng isang conductor. So nakadepende siya sa tatlong bagay. Una, sa type of material or nature of material through resistivity. So gagamitin natin dito yung table na pinakita ko sa inyo kanina. And then, depende din siya sa length ng conductor. So, length ng conductor, and then pati na yung cross-sectional area. So, the more na mahaba yung conductor, syempre, tumataas din yung resistance niya. Okay? At the more na lumiliit yung cross-sectional area, tumataas din ng resistance niya. Kasi ano bang nangyayari pag mas mataas o mas malaki or mas maliit yung cross-sectional area? So, na-imagine nyo ba, saan ba mas madaling mag-move yung charges? Sa mas malaking cross-sectional area or sa mas maliit na cross-sectional area? So, syempre, dahil mas malaki yung cross-sectional area dito, madali. Okay, tama. Mas madali yung motion niya dito. Kasi yung space is mas maluwang. Kaya mas madami siya. Tama, walang traffic. Kung analogy ang pag-uusapan, walang traffic dito. Kasi okay, yung daan ay maluwang. So maluwang yung daan. Unlike dito, makitid yung daan. Kaya mas madali yung motion ng charges dito. Kaya yung current ay mas mataas or hindi nahihirapan yung charges na mag-move. Kaya yung resistance niya ay mas mababa pag mataas yung or malaki yung cross-sectional area. Yeah, so that's one way of limiting the resistance of a conductor. Medyo lakihan mo yung cross-sectional area. Pero syempre may disadvantage din yon. Una, bibigat siya. Pangalawa, baka mas mahal siya. Kaya kinocompensate mo na lang sa ibang bagay. Okay? Ayan. So, dyan natin nakuha yung formula na rho L over A in computing the resistance of a conductor. Okay, any question? Okay, so yung pagkuha ng resistance, ayan, so meron tayong, hindi na natin to gagawin. So, yung pagkuha ng resistance ng mga resistor, hindi na natin yung gagawin. Okay, pupunta na tayo sa, okay, ang relation ng resistance at saka resistivity. So, based ito sa formula, kung tumaas yung resistivity, so that means tataas din yung resistance. Ayan. Okay? Tataas din yung resistance. Pag tinaas natin yung resistivity. Ngayon, anong relation ng resistance sa temperature? Kung tumaas yung temperature, class, tumataas din yung resistivity. So kung tumaas yung resistivity based on sa formula, tataas din yung resistance. Kaya kung tumataas yung temperature or umiinit, so ibig sabihin, tumataas din yung resistance. Ayan. So, ang nagbabago yung resistivity based dito sa formula na to. So kung tumataas yung temperature, tumataas din yung resistivity. At ngayon, ito yung formula. So yung final resistivity is equal to the initial resistivity times the quantity 1 plus alpha times the quantity final temperature minus the initial temperature. Yung initial temperature na to, related siya dito sa initial resistivity. At yung final temperature, syempre, related siya sa final resistivity. Ngayon, ano yung alpha? So yung alpha ay, yun yung mga value nung sa table kanina. So ito yung alpha. Okay, so nandito yung temperature coefficient. So dito natin kukunin yung temperature coefficient na based dun sa formula natin. Okay, ang ano lang class is tatandaan ninyo, all values are at 20 degrees Celsius. Okay, so lagi nyo tatandaan yon that all values are at 20 degrees Celsius. Okay, so nandito siya sa, ayan, sa formula na yan. So kung tumataas yung temperature, tumataas din yung resistivity. So tumataas din yung resistance. Ngayon kung resistance yung given at hindi resistivity, so that means pampapalitan lang natin ay yung resistivity, gagawin lang natin siyang resistance. Ayan. So same lang naman ng formula, so mapapalit lang na to in terms of resistance, not in terms of resistivity. So alpha is the same, dun pa rin sa table na yun kukunin. Okay? Okay, so ang last one ay na power na. Di ba ang power natin is work over time, so that's joules per second. Okay, so that's 1 watt. Pero ang power natin in electrical power, so that's equal to current times voltage. Pero meron tayong dalawang formula ng power. So kukunin natin siya in terms of V is equal to IR. If ito is substitute natin siya dito, so that means power is equal to I squared R. Okay, so ang formula to actually ay ginagamit pang compute ng energy loss. Yeah. So energy loss sa conductor. Kung meron kang resistance ng conductor at saka current flowing through it, mako-compute natin yung power loss dun sa conductor mismo. And mostly, yung power loss na to is nako-convert siya into heat. Ayan, umiinit. Kaya class, pag sinabi ng nanay ninyo na patayin nyo na yung TV kasi mainit na siya at magastos sa kuryente, totoo yun. Totoo in a sense na yung power ay tumataas, nagagastos, at hindi na efficient yung device or yung equipment ninyo kasi masyado na siyang mainit. Kailangan palamigin muna. Kasi masyado na siyang tumataas yung kuryente na na-absorb niya. And most of it is nako-convert siya into heat or nalo-loss. Okay? Nawawala. And then the other formula, if we will convert this in terms of I, substitute natin siya. So that's equal to V squared over R. Ayan. Okay, paano naging watts din yan? Or paano naging joules per second? Yun yan. Ang unit, ang formula na yan. Ano ba yung current natin na ampere? So that's coulombs per second. At ang voltage natin, so kukunin natin siya dito. Ang electric field kasi is Newton per coulomb meter. But Newton meter is joules per coulomb. So that's equal to joules per coulomb. Cancel nyo yung coulomb, so we'll have joules per second, which is also watt. Okay? Ngayon, ang tanong ay class. Wala ba kayong tanong? O meron akong tanong. Ang tanong ko, class, ay, ang current ba ay vector or scalar? Ang current ba ay vector or scalar? So habang sinasama yung question, do you have any question? Other questions? Ayan. So kung wala na kayo ibang questions, so let's solve this example. Okay. So the quantity of charge that has passed through a surface area of 4 centimeters squared varies with time according to the equation. Q is equal to 8t cubed minus, okay, what's our equation? So Q is equal to 8t cubed minus 2t squared plus 8t minus 5, where t is in seconds and Q is in coulomb. So what is A? The average current from 3 to 5 seconds. Okay, what's the average current from 3 to 5 seconds? Okay, so letter A. Ang average current natin ay equal siya sa delta Q over delta T. So that's equal to Q final minus Q initial over T final minus T initial. Ayan. Okay, so kailangan natin ng T final at saka ng T initial, Q final at saka ng Q initial. Kaya lang we're given only yung time initial and time final. So gagamitin natin yon. So ang T initial natin is 3 seconds. So therefore, what's Q initial? So substitute lang natin. So 8 times 3 cubed minus 2 times 3 squared plus 8 times 3 minus 5. Pwede bang pa-compute? And then T final natin is 5 seconds. So Q final is 8 times 5 cubed minus 2 times 5 squared plus 8 times 5 minus 5. Ayan. So, ano ang Q initial? Tama ba ako? 217? Column? Class pa, check na lang. And 985 column. Okay. So, tama ba? Okay. So, that means, tama ba? Tama, no? Okay, so therefore, substitute na natin siya dito. So, 985 minus 217 over 5 minus 3. Okay, 384 amperes. Ayan, 384 amperes. Okay? Okay, now letter B. So what is the instantaneous current? So instantaneous current is dq over dt. So that means get the first derivative. So that's 24t squared minus 40 plus 8. So current at 2 seconds is 24 times 2 squared minus 4 times 2 plus 8. So the current is 96 amperes. 96 amperes. Okay? Next, letter C. So what is the current density at 2 amperes? So current density is equal to I over A. But what is I at 2 seconds? Okay, it so happened, class, na 2 seconds yung A at saka yung B at saka yung C. So pareho sila. So that means pwede nating gamitin yung 96 amperes. Kasi yun yung current at 2 seconds. Pero kung 3 seconds yung nakasulat sa C, so let's say what's the current density at 3 seconds? So kailangan hanapin muna natin yung 3 seconds na current or yung instantaneous current at 3 seconds bago natin kunin yung current density. Pero since ito at saka to pareho sila, so pwede natin gamitin yung 96 amperes. Okay, so therefore, J is equal to 96 amperes over yung area natin na 4 cm squared. So convert lang natin. So 1 meter over 100 cm squared. So that's equal to okay, 240,000 joules per, amperes per meter squared. So this is the current density. Bakit kinonvert? Ang SI unit kasi natin ay meter squared. That's the SI unit of current density. Okay? Okay, next one I... Okay, so let's have the next one. Okay, so a current of 5 amperes exists in a 10 ohm resistor for 4 minutes. How many A, coulombs, and B, electrons pass through any cross-section of the resistor at this time? Okay, so we are given that the current is 5 amperes and then the resistance is 10 ohms and the time is equal to 4 minutes. Okay, tinatanong A, what is the total charge? Ayan. Okay, now yung unknown natin, how are they how is it related to the given? So is it related to current? Okay, so ang current kasi is equal to Q over T, di ba? So that means Q is equal to IT. So that's equal to 5 amperes times 4 minutes. But let's convert that into seconds kasi ang ampere natin is coulomb per second. So that's for every minute, meron tayong 60 seconds. So cancel, cancel. So therefore, our charge is 1,200 coulombs. 1,200 coulombs. Okay, letter B. So ilang electrons sa 1,200 coulombs na yan? So there are two ways to solve it. So yung una, yung 1,200 coulomb, i-convert mo na lang into a number of electrons. So ang 1 electron kasi, so meron siyang charge na 1.6 times 10 raised to negative 19 coulomb. So cancel mo siya. So magiging 7.5 times 10 raised to 21 electrons. Ayan. Okay, class. Hindi ko sinali yung negative kasi number yung pinag-uusapan. Number. Ilan. Mahirap naman yata. Ilan sila? Dalawa. Negative 2 sila. Kaya hindi ko na sila yung negative. Kasi number yung tinatanong. Okay? So what's the other way? Di ba ang total charge ay equal siya sa total number of charges times the charge of each. Or yung number of charges is equal to total charge over the charge of each, which is 1,200 coulomb over 1.6 times 10 raised to negative 19 coulomb. So the answer is still 7.5 times 10 to the 21. Okay? Okay, so let's proceed to the other one. Okay. Wait, class. Ayan. Okay. So a rod of 2-meter length and a square cross-section is made of a material with resistivity of 6 times 10 to the negative 8 ohm meter. If the potential difference of 0.5 volt is placed across the ends of the rod, at what rate is heat generated in the rod? Okay, so ano bang hinahanap natin? So heat is an energy, kaya lang rate yung hinahanap. So that means that's energy over time. So therefore, power yung hinahanap natin. So power. Ngayon, ano ba yung given natin? Given tayo ng length na 2 meters, ang area na 2 millimeter by 2 millimeter, kasi square siya. And then yung resistivity is 6 times 10 raised to negative 8 ohm meter. And then the voltage is 0.5 volts. Okay, kung titingnan natin, ang L, A, and resistivity has something to do with resistance. Okay? And then yung V natin, V yung given. So that means yung power, ang gagamitin na lang natin ay V squared over. Huwag na natin idadaan sa current. Okay, diretso na natin sa voltage squared over R. Okay, kunin lang natin yung resistance. So ang resistance natin is rho L over A. So that's equal to 6 times 10 raised to negative 8 times 2 meters all over. Ang area natin is 2 millimeter by 2 millimeter times, convert natin ng 1 meter over 1,000 millimeter squared. Ayan. So what's our resistance? It's 0.03 ohms. So therefore, power is equal to 0.5 squared over 0.03. So power is equal to 8.33 watts. So the answer is letter C. Okay? May question ba? Let's proceed to another one. Ayan. Okay. Okay, the electron density in copper is 8.49 times 10 to the 28 electrons per cubic meter. When a 1 ampere current is present in a copper wire with 0.4 cm squared cross-section, the electron drift velocity in meters per second with direction defined relative to the current density is. So, hinahanap natin is yung drift speed or drift velocity. Drift velocity pala. So, drift velocity yung hinahanap natin. So, given tayo ng N, I would say that's 8.49 times 10 raised to 28. electrons per cubic meter. And the charge of each is negative 1.6 times 10 raised to negative 19 coulomb. The current is 1 ampere and the area is zero point 0.4 cm squared. So what is the drift's velocity? Ayan. So, given tayo ng drift in relation to current, di ba ang current natin ay equal siya sa NA VDQ. So therefore, ang VD natin ay equal siya sa I over NAQ. Yeah. So that's equal to 1 ampere over 8.49 times 10 raised to 28 times 0.4 cm squared. Convert natin ng for every meter, meron tayong 100 cm squared times yung charge ng isa, negative 1.6 times 10 to the negative 19 coulomb. Okay, what is the drift speed? It's negative 1.84 times 10 to the negative 6 meters per second. So the answer is A. Okay, so let's proceed to the next one. Ayan. Okay. So a fuse in an electric circuit in a wire is a wire that is designed to melt and thereby open the circuit. If the current exceeds a predetermined value. Suppose that the material to be used in a fuse melts when the current density rises to 440 amperes per cubic centimeter. What diameter of cylindrical wire should be used to make a fuse that will limit the current to 0.5 ampere? So we're given that the current density is 440 amperes per cm squared. And the current is 0.5 ampere. Ayan. So, tinatanong ano daw yung diameter. Now, how are these two related? Ang J kasi ay equal siya sa I over A. Wherein A is equal to, since cylindrical yan, so that's pi over 4 d squared. Ayan. So, therefore, J is equal to I over pi over 4 d squared. Cross multiply lang natin. So, ibig sabihin, d squared is equal to I over pi over 4j. And then we square both sides. So, d then is equal to the square root of, what's I? I is 0.5 ampere over pi over 4 times 440 ampere per cm squared. Cancel natin yung ampere. Tapos hindi ko na kinonvert, so ibig sabihin ang sagot natin ay naka-cm na. Hindi naka-meter, so naka-cm. So square root of 0.5 over pi over 4 times 440. Ayan. So that's equal to 38.04 times 10 to the negative 3 centimeters. Ayan. So this is our final answer. Okay, question? Ayan. So let's have another one. Ayan. Okay. So a certain X-ray tube operates at a current of 7 milliamperes and potential difference of 8 kilovolts. Okay, what is its power in watts? Okay. So given tayo ng current na 7 milliampere and then yung voltage is 80 kilovolts. So tinatanong ano yung power? So power is VIV, so that's equal to 7 times 10 raised to negative 3 ampere times 80 times 10 to the 3 volts. The answer is 560 watts. So the power is 560 watts. Okay. Okay. So the next one ay ito. Okay. What is the resistance of a 1,200 meter of a 2 millimeter diameter copper wire? If the resistivity of copper is 1.7 times 10 raised to negative 8 ohm meter. Okay, resistance is equal to rho L over A. So that's equal to 1.7 times 10 raised to negative 8 ohm meter times 1,200 meter all over. So diameter yan. So pi over 4 times 2 millimeter squared. So convert natin yan ng 1 meter over 1,000 millimeters squared. Okay, so what is the resistance? Six point 49 ohms. Tama ba ako? Ulit. Okay, 6.49 ohms. Okay, so any question? Ayan. So kung wala na kayong question, so that's it for today.